So we'll capture everything. So a body projected vertically upwards and returns back to it. Now, this is vertically upward motion. This question falls on vertically upwards motion. Class, when a body is projected upwards, what happens to its velocity? When a body is thrown to go up, what happens to its velocity? Anybody to share something with me?
Decreases.
So technically, it decreases. Technically, how do we describe it? If its velocity decreases whilst it's going up, technically, how do we say it? That the body is,
decelerating.
Decelerating. So when it's going up, when it's moving up like this, the body decelerates. And we are told that it is thrown to go up and returns back to its starting point. So it must go up and come down. When it is coming down, what happens to it? When it is coming down, what happens to it?
Accelerate.
It accelerates, meaning the velocity increases as it is falling downwards. So it accelerates. So if it is going up, it must decelerate. Then will its starting velocity be maximum or minimum?
Maximum.
It must be maximum, so that by the time it gets to the maximum height, the final velocity would be 0, isn't it? Then if it is coming down, what will be its initial velocity at the point where it just stops and returns to the ground? What will be its initial velocity at that point?
0.
0. Then the final velocity just before it hits the ground, how would you describe this velocity? How would you describe the velocity? Just, it must be maximum. Okay. So let's then plot our graph. Let's then plot our velocity time graph. So this is t/seconds. This is v/meter per second. Of course, this is a 0 for the time and for the velocity. Now, when it is just projected to go up, its velocity must be maximum. Then when it gets to the maximum height, it must decrease to 0. Okay. So this is where the moment the graph touches the time axis, it means that the velocity is 0 at that point. Class, are you with me? Do you agree with me on this point? Hello, do you agree with me on this? Oh, let me hear from you. So we are starting with a maximum velocity. It will be decelerating or decreasing as the object goes up. By the time it gets to the maximum height, the velocity is 0. Then, when it is returning from the maximum height to the point where it is initially thrown, its velocity will be increasing. This is how the graph must be. Yes, I saw some of you giving me this. Giving me this graph. Giving me this graph for VT graph. This will not be completely accepted because when you do this, you mean the changing velocity is only occurring along one direction, along the positive direction. Okay, but when the object is going up, the changing velocity one direction, and when it is coming down, it also occurs along the other direction. So this must be it. So that just before it hits the ground, this must be the maximum velocity. And it appears to be negative because it is occurring in the opposite direction to this one. Please, are we okay?
Yes, please.
Yes. Then the other one, an oscillating pendulum moving from maximum displacement to the equilibrium position. And here we all know that for an oscillating body, yesterday we drew such a graph. For an oscillating body, its velocity is minimum, actually zero at the extremes, and maximum whenever it is crossing the equilibrium position. So if it's a graph of velocity time graph, then V against T. When it is just here, when V, don't forget this is the point where velocity is zero. V is zero at this point. As we move up, the velocity will be increasing. The velocity will be increasing. Okay, so at the point where velocity is zero, then it means we are at the extremes, where the amplitude is. So velocity must be zero here, so that it's like starting from moving from the maximum displacement, which is one extreme, to the equilibrium position. Okay, so whether you take it from this point or this point, they are all maximum displacement, the extreme. So the graph must be this. And by the time the body crosses the mean point, we have its maximum velocity. Okay, it can't be half, because you can choose to come from here or come from here. And so the shape is the mirror of whatever happens at the other side. This must be the velocity time graph. Please, is there any question? Is there any question?
No, sir.
Elizabeth, are you okay?
Yes, please.
All right. So it's good to be solving questions so that at least we'll learn from our shortcomings. I want to quickly give some warm-up questions. So listen and then write it for me. The displacement equation of an oscillator the displacement equation of an oscillator is given by y is equal to 5 sine, open a bracket, 0.2 pi t plus 0.5 pi. Calculate the time period or the period of oscillation. Your task is to calculate the period of oscillation. So if you are given a displacement equation of an oscillator or a body executing SHM to be this, calculate the time, the period of oscillation, capital T. Are we through?
Yes, sir.
Can you come again?
Yansabwako, what's your answer?
You said please, I'm on it.
Nathaniel, what's your answer? Mamiya, what's your answer? Hey, Elizabeth, what's your answer?
Still here, please. I'm not done with it.
Oh, then there's trouble. Frida, what's your answer? Kezia, Adoma, Bilal, what's your answer?
Say please, I'm working on it.
Angel, give me an angelic answer. Efia, Elsie, Darius, Bridget. I'm waiting for all. Frederick, if you are delaying, then there is a problem. If you are actually delaying, there is a problem. Let's quickly do this. When you are giving Y, okay, somebody has given an answer. Let's see. Ronnie. Ronnie had 10 seconds. We shall see, Ronnie. If you really run the show, Ronnie. Compare this with Y is equal to A sine omega T. Mamiya, what's your answer?
10.
10 Ghana cedis.
10 seconds.
Okay. Okay, so let's see. Omega is equal to 0.2 pi. And omega is 2 pi over the period. So 0.2 pi. Pi will cancel this out. And so we have 2 over T is equal to 0.2. T therefore must be equal to 2 divided by 0.2. And this is 2 over 2 on 10, which will be equal to 2 over 1 times 10 over 2. The answer therefore is equal to 10 seconds. So Ronnie and Mamiya actually got it right. Okay, and I'm sure a lot of you also got it. Maybe because of the time, Bilal also. So another question. A particle executing SHM has an acceleration of 64 centimeter per second squared. It has an acceleration of 64 centimeter per second squared. When its displacement is 4 centimeter, so when y is equal to 4 centimeter, its acceleration is 64 centimeter per second squared. What is its period of oscillation? Start work. So 2 minutes. 2 minutes. Let's make it NSMQ. 1 second. 1 minute. So
Say the amplitude.
no, it's the acceleration. Glenn, please mute yourself for me. Two minutes. Oh. One minute more. Thirty seconds. Okay, let's see. Okay, so Bilal is saying 1.5. Oh, Bilal, okay, to this particular question, right? Ronnie is also giving us 1.57. Leslie is giving us 1.57. And Yansabuakwa is also giving us the same value. Majority cannot always win. Stop work. Time is up. Time is up. So, if acceleration of a body executing simple harmonic motion, magnitude of acceleration is equal to the square of the angular velocity times the displacement. Therefore, if A is 64, omega squared, 64 centimeter per second squared occur at a displacement of 4. Therefore, omega squared would be 64 on 4. Class, what is 64 on 4?
Yes, 16.
16. So that omega is equal to square root of 16, which is 4. Omega is also 2 pi on t. So this is equal to 4. Pi on t is equal to 2. Therefore, t would be equal to pi on 2. Pi is 3.142 approximately divided by 2. And so this must give us the answer, which is broadcast on the airwaves, 1.57. Okay. Angel, Eva, are you there? A body executes SHM. A body executes SHM. Glenn, I cannot blend your background noise. Glenn, a body executes SHM with an amplitude A. The amplitude is A, capital A. What is it? Its energy is half kinetic and half potential when the displacement is equal to what? So a body executes SHM with amplitude capital A. Its energy is half kinetic and half potential when the amplitude, when the displacement Y is equal to what? That's the question. Or which displacement would give us the energy which is half kinetic and half potential? That's the question. So at what displacement Y will its energy be half potential and half kinetic? Half KE and half PE. So what is the kinetic energy equation of a body executing simple harmonic motion? So Bilal is giving us an answer. 0.707 of the amplitude. We shall see. Kinetic energy of a body executing simple harmonic motion is given A root of 2. A divided by root of 2. Okay, let's solve it and then see it. This is half mv squared, but v squared. Let me take it bit by bit. Because v is equal to omega root of a squared minus y squared when we square this, we must square this as well. So this will give us omega squared times a squared minus y squared. So therefore, the kinetic energy is equal to half m omega squared a squared minus y squared. Then the potential energy, obviously, once we were not told that it is gravitational potential, we take it as elastic potential energy, which is half m omega squared times y squared. So if it is half potential, half kinetic, then they are equal at that point. So half of kinetic, which is half m omega squared a squared minus y squared, equal to half potential, which is also this, y squared. So when we equate them, a squared, all this will cancel out. This will cancel out. And we'll have a squared minus y squared is equal to y squared. So that a squared is equal to 2y squared. Therefore, y squared will be equal to a squared over 2. Y therefore would be equal to square root of a squared on 2, which is a over root of 2. And this will give us displacement y being equal to, okay, this can also be expressed as 0.707 times the amplitude. So I think all those of you who sent your answers, I think you are spot on. In fact, it is a very good thing you are doing. You are actually applying. Last question, then we move on. A very last question. The rest will be given to you. Please, if you are writing, let me know. Okay. Because you are not talking, it means you are not writing.
Please, I'm writing.
Hurry up.
Please, I'm done.
Okay. So, a body of mass 1 kilogram, 1 kg. It's executing simple harmonic motion given by the equation y is equal to 6.0 cos 100 t plus power on 4, where y is in centimeter and t is in seconds, where y is in centimeter and t is in seconds. What is the maximum kinetic energy? What is the maximum kinetic energy? I have a lot of these interesting questions to give to the house. The rest will chase you at your homes. What is the maximum kinetic energy? You have done 1 minute. You have 4 minutes more to go. What is the maximum kinetic energy? Is it challenging? If it's a challenging question, let me know so we can quickly solve it and move on. Bilal is giving us 18 joule. 18 joule. Ronnie. Class, I hope you are not using AI. Because these days, yes, AI is in the system. But if you overly depend on AI, it will affect your understanding. So let's actually take our time and then understand how to apply the concept in solving problems. Okay, so let's solve it. So we are given displacement equation or function. Now, the K kinetic energy or Ke maximum will be equal to half m times the maximum, the square of the maximum velocity. So all that we need here is the maximum velocity. If you are given a displacement equation or function, to get velocity, you must differentiate displacement with respect to time. Meaning, to have the velocity equation, we must differentiate this. So the differential of the displacement with respect to time is what I'm doing. So when I differentiate the displacement function, coefficient is always not affected by the differential. So we are actually going to deal with del dt of cos (100t) plus power on 4. So this is also a function of a function. So we differentiate the function within the brackets, and when we finish, we differentiate the whole cosine function. So the differential of this will actually be del dt of 100t plus power over 4 times del dt of cos 100t plus power on 4. Okay, so the differential of this would be equal to 100. When you differentiate 100t, the results will be 100. The differential of power over 4 is 0 because it's a constant. It has no t, the letter t. So it is a constant. A differential of a constant is 0. Then the differential of cos is equal to negative sine 100t plus power on 4. So it means that the velocity function is equal to minus 600 sine 100t plus power on 4. And this becomes the maximum velocity. V max is equal to minus 600. Therefore, the maximum kinetic energy would be equal to half times the mass, which is 1, times negative 600 all squared. And this will give us 360000 divided by 2, which will be 18 times 10 to the power 4 joule. Just is the answer. I know this is a bit above you since you haven't done differentiation and all that. But this will be the expression for the maximum kinetic energy. Please, are we okay?
Yes, sir.
No, please.
Leslie, which part?
Steady, I'm confused.
But which part? Let me know. which part is really...
The differentiation part.
In fact, as for the differentiation of, this is even of trigonometric function, unless you can understand it well, only when you have done differentiation of trig function. Okay, it's unfortunate as a physics person, I need to apply. Okay, but we don't have that time to actually go through. If we have enough time, I can expose you to it, but we don't have enough time. So sorry, when you grow, you won't understand. Okay.
This is the only way we can solve it.
Yes. So Bilal, if you are given a displacement function, to get velocity, you must differentiate the displacement with respect to time. If you are given displacement and you are to find acceleration, you must double differentiate it. Okay, so you differentiate the displacement 1 to get velocity, and you differentiate velocity 2 to get acceleration. So that is how it works.
Okay,
Is that
sir.
okay?
Yes, sir.
Okay, assignment. Please write this down. As for this, I think everybody would enjoy doing it. A body oscillates simple harmonically. A body oscillates simple harmonically according to the equation x is equal to 6.0 cos 3 pi t plus pi on 3 meters. What is A? What is A? Displacement. A, displacement. B, velocity. C, acceleration at time t is equal to, at time t is equal to 2 seconds. So a body oscillates simple harmonically according to the equation x is equal to 6.0 cos this. Note that this is horizontal oscillation. What is A? Displacement. B, Ronnie, I'm coming. What is A? Displacement. B, velocity. C, acceleration at time t is equal to 2 seconds. Find also D. Find also D, the frequency. Frequency F, the period. So you are answering 1, 2, 3, 4, 5. 5 questions. Okay.
Please, after the frequency, what again?
Period. Period. So A, displacement, B, velocity, C, acceleration at time t is equal to 2 seconds. And find also D, the frequency, and F, the period. That is your assignment, first assignment. That is your first assignment, meaning that there will be other assignments. Ronnie.
Sir, please, I wanted to ask with a question on the maximum velocity.
Maximum
Please,
kinetic energy.
Yes, sir, sorry. I wanted to ask that to find the maximum velocity, can't you just multiply the amplitude and the angular acceleration to give me?
A big no. Ask me why.
It's right.
Good. Note that we obtain this equation when we considered a vertical oscillation in terms of sine. So in those equations we derived, we did that on consideration that it was a vertical oscillation, out of which we had the velocity equation to be A omega cos omega t. Ronnie, if you recall. Right?
Yes, sir.
Good. So we then express this in terms of displacement and got omega times a squared minus y squared, where we realize that when y is 0, we have V max equal to omega times a. So we actually derived it when we were using a vertical oscillation in terms of sine. If you are given a cosine, you must treat it as such to obtain the expression for the maximum velocity. Are you okay?
Yes, sir.
So that's why you cannot use this to find the maximum velocity, so that you just substitute that into the equation and go scot-free. Right? Ideally, we should have considered every situation, but I felt that when I expose you to one, you can apply the knowledge to get when it is fine. That is why. So spend time to also go through this, all right? Yesterday, we were talking about applications of simple harmonic motion in practical terms. So we discussed a simple pendulum, and we were also looking at the helical spring or the loaded spring. Let's look at this. So under simple pendulum experiment, we are given a certain L length of a string or thread suspended on a rotor stand. This is the pendulum bulb. And the idea behind this experiment is to use this to estimate. Sometimes we use this to estimate the value of acceleration due to gravity J. So in the lab, you'll be given different lengths. And then be told to oscillate it, my lines. Oscillate it to get the time for a certain number of oscillation. So let's assume our values are in that decreasing order. So let's just a quick one for the sake of what we are doing, and then we move on. So if it is in that decreasing order, let's assume initially you are to begin with 100 centimeter length of the string. Please, I'm not writing just 100, but I'm writing 100.0, 90.0, 80.0. Then let's end at this. My first question to the house is that why are we writing 0.0 and not the values 100, 90, and so forth? Can somebody help as to why we write that? And if we don't do that, is that wrong? Mamia?
Because the measurements are taken with a ruler, and the least count for a ruler is 0.0.
Okay, so in the lab, whenever you take measurement using an instrument, you must consider the least that instrument measures. Okay, what Mamia said to be the least count. And since the least, the meter rule, which is used for taking the measurement, is 1 millimeter. 1 millimeter is also 0.1 centimeter. So once I'm expressing my length in centimeter, then it must go with the least it measures. Okay, that is why it is going with the whole value and then 1 dp recorded. So you must, whenever you take measurement using the meter rule, you must indicate the least count of that instrument. Else, if you just write 100, 100, 190, blah, blah, we'll subtract marks. You'll be marked down in a table of values and we'll deduct marks. So we are interested in time taken but for precautionary sake, for precaution, I'm taking double measurement. So T1 and T2. When I finish, I find the average time. We write the unit on top so that we will not be repeating the units whenever we write the quantity. So T1/seconds, T2/seconds, and T average also /seconds. So that if I did not write this, then you'll be seeing 100 centimeter, 90 centimeter, which is not acceptable. But whenever you do it, then it takes care of all that unnecessary repetitions or necessary repetitions. Please, if you have anything to ask, note it down. Okay. Now, in recording the time, you must displace this to move, and then you time for that number of oscillation. So when I move it to the right, it must go and come to give me one. So 1, 2, 3. So whilst it is oscillating, I'm only interested in 20 oscillations. So I count and time for 20. Then record my time here. Let's assume we can even calculate this to be accurate. Okay, so we have the period T to be equal to total time over N. And the same period is 2 pi root of L over G. Therefore, total time will be equal to 2 pi N times root of L over G. I'm beginning with 100. So I have 2 times 3.142 times the number. Maybe I'm to count it for 20 oscillations. So times 20 divided by, I'm beginning with a length of 100. So I must change that to meter, 1 meter divided by 10 meter per second. And I'm doing this because my acceleration due to gravity in meter per second. So please calculate it for me. Calculate the total time for me. So 40 times 3.142 times the root of 0.1. Let's hurry up. It should be around 37 point something. Ronnie, Mamia, and the rest of you, I'm waiting.
39.74.
So if I'm recording this, is that
39.7435.
I'll record this to 2 dp, 39.74. This is because, you see, ideally, I'm not supposed to use this to determine. I must actually conduct the experiment to get this. So this time must be determined by the stopwatch. But because I'm not in a laboratory setting, I'm using the formula to get it. So if you understand this, yes, it saves time, because at the end of it, if you are doing the right thing, the time you will get when you actually conduct the experiment and this time must be very close. They must be the difference will be the decimal point. But if you use formula and you make the mistake to record it as how Mamia, you gave me 39.748, straight away we catch you that, oh, he or she did not actually perform the experiment, but he used the formula. So you would even betray yourself just by your record, because no stopwatch would record up to 4 dp. The maximum will be 2 dp. Please, do you get it?
Yes, sir.
But you can actually use the formula if time is not on your side. Instead of doing just swinging and then counting that 20 oscillation and timing, and you will get the same thing. But you must be very careful when recording so that you don't give yourself up to them. Okay. Then you do it for 90, 80, 70. When you take it twice after recording all this can we fill it for 90, 80, up to 70? Please share. One of you must take 90, another 80, 70. I just want us to fill it to understand what you are doing. Share. Somebody should pick 90, 90, 80, blah, 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 and then if you are ready with what you picked, quickly share it with me. Who picked 90? Who picked 80? $70. Ubianya ready.
Sir, please, is it for the same 20 oscillation?
Pardon?
Is it for the same 20 oscillations?
Yes, it's for the same 20 oscillation. Frida.
Okay.
Please, for the 90, I had 37.68.
37.68. So you are recording up to 2 dp because ideally the stopwatch must give you this result. 80.
35.53.
35.53. Then 70.
33.25.
And if you are really doing the experiment and then get these values, how to check to ensure whether you are correct or wrong is this. You see, the period is directly proportional to square root of the length. And period is also T over N. So it means that T over N is also directly proportional to this. T is directly proportional to N times root L. Don't forget N is a constant, 20. So once this is a constant, when L increases, your T must also increase. When your T is decreasing, when your L is decreasing, your T must also decrease. So if you look at our values, we are decreasing value of L. And so we also have decreasing values of T. So if it follows the trend, you are good to go. If it doesn't follow, that's why I say. So during marking of practicals, we are not even interested in your values, the values you are getting. All that we are interested in is that does the experiment follow the trend? And what is the trend? The trend is that as the length decreases, time must also decrease. As the length increases, time must also increase. Class, are you okay?
Yes, please.
Yes, sir.
Your second T values must be almost the same. Okay, the difference must be within the decimal point. So maybe 39.62 accepted. The moment you are getting a value which is, and this is how we do it. Sometimes this is for T value, this is decreasing T. After you've ended at the last length, then you pick it upwards, 70, 80, 90, 100. So this is increasing length, okay? And the values must be almost the same. The difference must just be within the, the decimal point. And we do that for precautionary sake, for precaution, so that if there is wide difference, you can identify that no, then one measurement never went well. Please, are you fine? Okay. Then you look at your average T, your average value, maybe 6, 0, 37, 37.62. Okay. Your average value. The average value is a calculated value. You are using your calculator to calculate or determine. This has nothing to do with an instrument. So it's just this plus this divided by 2. If your stopwatch records 2 dp, then this must, to create that difference, the average value must also be expressed in 3 dp. Example, add 39.74 to 39.62 and divide by 2 for me. 39.74 plus 39.62, and then divide that by 2.
It's 9.68.
39.68. In order to create that difference between values obtained using the instrument, I'll record this in 3dp, 39.680. If your stopwatch also record in 1dp, then you can express the average value in 2dp, just to create that difference. That in the first T1, T2, you use instrument, but in the T average is a calculated value. Class, are you okay?
Yes.
Yes, sir.
Okay.
Yes, please.
The next entry, it actually depends on the instructions of the question. If the question demands that you find the period slash unit, period is equal to T average divided by the number of oscillations. And it is also a calculated value. And so it can be expressed in at least 3dp. At least 3dp. So the first one, your average time is 39.68. Okay, so 39.68, 680 is the same as this, divided by, maybe you oscillated it for 20 times, divided by 20. And you express this in at least 3-4 dps. It can be 3, it can be 4, but we don't do it. We don't record so many decimal places. When you do that, you are more or less lettering around. you are lettering around with decimal figures. So at least 3-4 dps accepted. This is because this is not a value obtained using any instrument, but it's a calculated value. So you are good to go. Then let's assume, so please calculate this one for me, the T. Let's assume that the question also asks you to, the instruction also asks that find T squared, the square of this period. So what did you make for 100? What did you make for T, the period?
1.984.
So 1.9840. Okay. Then the square of this same value, square it for me. Square it for me. Oh, 1.9840 squared.
3.9363.
3.9363. And I'm writing it in 4dp because it's also a calculated value. So that is what you must do for all of the length. Meaning, what the T actually means is that if your length is 100 centimeter, this is the time it will take to make one complete oscillation, 1.984. That's what it means. Okay. Any question? Is there any question here? Is there any question? All right, no question. So let's look at the plotting of the graph. Let's assume you are asked to plot a graph of T squared on the vertical against L on the horizontal, what does it mean? And the other instruction can be that maybe if this is just it and there's no other instruction, so this implies that my vertical must be t squared. My horizontal must be L. If the instruction of the graph is open like this, then listen and listen very well. You see, my minimum length to record is 70, followed by 80, meaning from 0 to 69. I wouldn't plot till I get to 70. If the instruction is open like this, plot a graph with t squared on the vertical against L on the horizontal, I can decide to break my axis. What do I mean by breaking the axis? Because my least length to plot is 70, I can decide to start from maybe 65 or 60. It depends on these values. So instead of starting from 0, maybe 5, 10, blah, 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 I can break the axis and begin with 65, or if I want it in 10, 10 intervals, 60, 70, 80, 90, 100. If the instruction of the graph says that plot a graph of t squared on the vertical against L on the horizontal, starting both axes from the origin, ladies and gentlemen, I cannot break the axis. I must compulsory start from 0. So my axis must be continuous. In that case, maybe 0, 10, 20, 30 till I get to my first point to plot. Or 0, 20, 40, 60. So whenever you are plotting the graph, you need to listen to the instruction. Am I supposed to start both axes from the origin? If yes, then know that you cannot break the axis. If there is no such instruction that starts from the origin, you can break it. However, even this, you must read further to ascertain that is there a sub-question that demands that you find intercepts on any of the axes, intercept, where the graph cuts either the vertical or the horizontal axis. This is because if there is a question on intercepts on any of the axes and you break the graph, you may miss the point where it cuts the vertical or the horizontal axis. So if there's a question on intercept, then you also do not touch that axis as well, even though you are not restricted to starting from the origin. Please, is that okay?
Yes, please.
So there are instructions. If there is no intercept, if there is no, oh, hooray, I can break the axis and go. So that is it. Any question? Leslie.
Mr. Dia, please, the breaking of the axis, is it the same as the breaking of scale?
Yes. That's
And
the
also,
same.
if you break the axis, is there like any, I don't know, any sign to indicate?
Physics, no. The mathematics, that's zigzag. Physics, no, there's no sign. Once you are not, it is not continuous, I can see that this axis or the scale is broken.
Yes.
So in physics, we don't indicate any zigzag thing to denote that this axis is broken. Please, is that okay?
Yes, please.
All right. Then, because this graph is such that t is directly proportional to square root of the length, when you plot, you must get a straight line. You must have a straight line. The instruction is that find the slope. So in determining the slope, you pick 2 points on the straight line. 2 spaced out points, not close points, because your rectangle must be so large. So this is change in the horizontal against change in the vertical. So delta t squared / 8 units against delta L / 8 units. Therefore, your slope must be equal to change in t squared / the units divided by change in L / a unit. Now the question is, what is the significance of this slope? You see, you can derive whether your value of the slope is correct or wrong from this. From this formula. If you look at period is equal to 2 pi times root of L over G. When we square both sides of the equation, you have t squared is equal to 4 pi squared L over G. I want to divide through by L at both sides of the equation. T squared over L is equal to 4 pi squared over G. Class, what is this? What is this at the left-hand side? Can somebody help?
It's the slope.
That's the slope. So it means that your slope S is actually equal to 4 pi squared over G. In numerical terms, it means that your value must be around 4 times 10 over 10, approximately 10. A pi squared is around 10, 3.142 squared is close to 10. So it means your slope S must be equal to around 40 or 4. Around 4. And that is, if you this, don't forget, this is in meter per second squared. Okay. This is in meter per second squared. If you change it to, please, Elsie, please mute yourself. If you change it to centimeter per second squared, S must be around 400. 400. If you change 10 meter per second squared to centimeter per second squared, you have your slope to be around 400. Okay. So when we are marking, whenever we are marking, this is what guides us. This is what actually guides us, because this is an experiment, we take 10% plus or minus of the theoretical value, whether 4 or 400. So we use the 400 since we didn't convert our length and all that. So 400. So whenever you fall within 10% plus or minus of this theoretical value, then you are correct. We mark it for you. Are you okay? Then sometimes, after determining the slope, you will be asked to find the letter C is equal to 4 pi squared divided by your slope. Find a letter C equal to 4 pi squared divided by whatever you got for the slope. What is the significance of this? What is the significance of 4 pi squared divided by the slope, class? Anybody to help? Elizabeth, are you there? Yeah. What is the meaning of dividing 4 pi squared by the slope?
Is it the acceleration?
Is the acceleration due to gravity? So look at it from the formula. It said we just saw that t squared over it does the slope, which is equal to 4 pi squared over j. And so if you make j the subject, you have j being equal to 4 pi squared divided by the slope. So if you got the slope value correctly, you must get a value which is also close to acceleration due to gravity. Don't forget, I earlier said we can use this experiment to estimate the value of acceleration due to gravity. So all that we are doing is that we are using the formula to find out the meaning of the questions, the sub-questions they ask us. That is just it. Please, are you okay?
Yes,
Class, are you fine?
Yes, please.
Sometimes instead of t squared against L, the same formula, they can manipulate it so that instead of plotting this, you plot, let me give you another possible graph questions under this. T squared, t is equal to 2 pi times root of L over G. And we can decide that plot a graph of T on the vertical against root of L on the horizontal. This is another possible graph that can be asked in typical practical. And what it simply means is that, you see, this T is equal to 2 pi root of L over square root of G. So if you divide through by root of L, so if the instruction is that plot a graph of T on the vertical against root of L on the horizontal, this is what it basically means. It means that when you find this slope, the slope must be equal to 2 pi divided by the square root of gravity. So to test whether you are correct, it's just 2 pi divided by root of 10 in meter per second squared. You can also, because you are not converting this, you can also change your 10 meter per second, which is acceleration due to centimeter per second squared. And you can use that to check whether your values your value of the slope is correct or otherwise. So this is just it. If you understand, that is why I always say that practicals is all about the theory. If you understand the theory, you can figure out whatever they are asking. Whatever they are asking, moments, current, electricity, simple pendulum, and all that. Please, is there any question? Is there any question? Ask questions, ask questions. Okay. Let me give you 5 minutes water break. Go for your usual water break and then come back after 5 minutes, okay? Or you don't want it?
Yes, we want it.
Okay, then go for it. I'll see you in 5 minutes time. Bye-bye. Angel. Angel. Hello, Angel. I just saw that where is the man? The man has gone home. Were you, did you go off?
Yes, please. The next way.
The man has gone home. Okay. I've given you 5 minutes break to return in, and we have about 2-3 minutes. 2-3 minutes to rejoin. Okay, so back from commercial break, back from water break. Because of our coverage, we can find another time for that discussion on the loaded spring. So we can start a new topic, which is wave motion. Okay. Let's find another time to discuss practical application on the loaded spring. Class, are you there?
Yes.
Yes, sir.
Okay, so wave motion. Wave motion. What is a wave motion or wave motion? But my question is that why do we associate somebody waving the hands or moving the hand back and forth to, oh, he is waving at me. She is waving at me. Why? There must be a reason. Why do we associate curly hair also to the waves? Oh, he has waves on his hair or the hair. Why? So what is wave motion? What is wave motion? Before we look at what wave motion is, that let me draw your attention to several applications of waves. In fact, we all find ourselves in an ocean of waves. We are within waves because before you can even talk to somebody to hear you out, is as a result of sound waves. Okay, the light, the visible light we receive from the sun is a form of wave, light wave. Heat from the same source, heat waves. Apart from that, internet communication, mobile telephony, mobile communication, okay, radio stations, television stations. So we find ourselves in waves. Waves are all around us. And so that makes it very, very important to go into what wave motion basically is. So when we say, or we talk about wave motion, what is it? The source of every wave, is as a result of vibration of the particles of the medium. So the source of every wave is due to vibration of the medium. So to initiate wave, there must be an external factor which causes particles to vibrate. Then the wave starts and continues on and on. Efia, are you there?
Yes, please.
So if you visit the beach, we see the ocean wave. This ocean wave formed is as a result of, you see, when you travel or go deeper, about 4-5 kilometers, even at the beach, you see the wind speed or velocity is so much. It gets so intense whenever you sail deeper, about 10 kilometers within the ocean. The wind intensity, very, very great. So whenever the wind blows, the energy of the wind just splashes the surface of the water. This energy is carried by the water, and then it is transmitted or propagated from the starting point on and on and on and on and dies out at the shore. So the ocean wave is due to the energy of the wind blowing and splashing the surface of the water, picked up by the water molecules, transferred to nearby water molecules on that continuity till it dies out at the seashore. So the first or whatever initiates it is the wind shaking the immediate water molecules and then traveling on and on to the other side of it. So we define wave motion as a traveling disturbance. Wave motion is a traveling disturbance that carry energy from one point or one region of a medium to another point or region. So a traveling disturbance that carry energy from one point or one region of a medium to another. This is the definition of wave motion. Class, are you with me?
Yes, sir.
Now note that waves transfer energy, but not matter. What it basically means is that when you visit the seashore, that thing which continuously rolls to the beach or the shore is energy and not actually water. Hence, the good old saying that the sea shore never gets flooded. The seashore never gets flooded because what you see to be rolling out continuously to the beach is not actually water, but it is the energy of the wind, which is propagated through the water medium or molecules. So waves transfer energy, but not matter. Please, is that okay? So when you speak, you see, whenever you are hungry, is talking easy or difficult? Whenever you are hungry, do you find it easy talking?
No.
Because you use energy to talk. And by talking, you are generating sound wave. So the energy causes your vocal cord, what sometimes we describe as Adam's apple, to vibrate. The source of every wave is the vibration. It's due to vibration. So your vocal cord vibrates. This vibration also causes the air column within your trachea to vibrate. The energy causes the vibration of the air around your mouth to also. So when you are speaking, just put your hand in front of your mouth and you see, you feel air hitting your hand. Okay. So there is that successive transfer of the energy through your trachea to the air, on and on and on, causing that vibration of the air particles, which is finally received by your pinna, your earlobe, then reflected into your ear canal. It goes to cause a vibration of very thin skin, eardrum. This is also picked by small bones within your ear, the inner part of the ear, and the final interpretation is done by the brain. So sound wave is as a result of a wave formation. And in this particular case, it is also energy from you which initiates it. That's basically it. Okay. So this is just the surface part of wave motion. We'll be looking at types of waves, the various types of waves. Then classification of waves. We have about 3 classifications. Then we look at the wave profile. The wave profile. Please, is there any question? If you want to be clear with something quickly, bring it up We have about 2 minutes to end the show. Any question? No question. If no question, then class, this is where I end today's show. We'll continue next week. I have given you assignment. Please, you can send it now, tomorrow, because another set of questions would reach your homes through the airwaves. So you better finish this, and then please, those of you who are not fan of answering questions, it's a very bad practice. Okay, to master the concept, you must apply it in solving questions. So I encourage you to be doing it. Okay, this is where we end the show. Thanks for your time, and we'll meet once again next week. Bye-bye.
Bye.
Yeah, bye.